Training everyone. In this video, we will see how to calculate effective diameter or pitch diameter using two-wire method. So in two-wire method, wires of two wires of known diameters are chosen such that they contact the flanks at their straight portion. You can see it in the picture below. Two wires, wire 1, wire 2, okay, they are placed in between the anvil and thread in one side and another side. If you place like this, we get some values on this micrometer that is considered as M, capital M. So M is nothing but distance over the wires that is directly taken from the micrometer. Okay, so as we know, this effective diameter, pitch diameter is nothing but the distance between two pitch lines. Okay, so you can see it in the diagram. So this is, if you see this diagram, this is the pitch line, this is another pitch line. Okay, the distance between these two pitch line is nothing but effective diameter or pitch diameter. In this derivation we will notate ES effective diameter. Okay, so that is the another notation we have to keep in mind. E is nothing but effective diameter. We can clearly understand what is effective diameter from the picture also. Okay, and another thing is that there is a term called T, capital T. It is nothing but distance between this line. This line is nothing but at which the wire rests on the flanks. Likewise, on the top we have one line on which this wire has been rested. Okay, so the distance between these two lines we are assuming it as capital T. Capital T. Okay, and there is some distance between this line on which this wire rests and then the pitch line. That distance, let us assume it as, I will take a notation for this as capital F. I will take the notation as capital F. Capital F by 2. Okay, so this distance is nothing but capital F by 2. Likewise, in the bottom also we have one capital F by 2. You can see the distance between the pitch line and the line at which the wire is resting on the bottom thread. Okay, that is taken as another F by 2. Okay, so we have seen three terms. One is M, nothing but distance over the wires. E, effective diameter, which we are interested to calculate through this two-wire method, and T, capital T, which is nothing but distance between the these two lines. This is the line at which the wire is resting on the flank. Okay, and then we have F by 2. F by 2 is nothing but distance between the pitch line and the line at which the wire is resting. Okay, so with these notations we can find out effective diameter. Okay, so what is effective diameter now? The distance over wires is M, right? One second. From the picture we can understand capital E, effective diameter, is nothing but this T distance plus F by 2 plus F by 2. Okay, you can see here this F by 2, this F by 2 plus T will give you the effective diameter. So E is nothing but T plus F. Okay, E is nothing but T plus F. Now how to calculate this T? T is nothing but, from the diagram we know this distance over the wires as capital M. This distance over the wire is capital M. Okay, if you want to calculate this T, okay, this T can be calculated by subtracting this diameter of the wire and this diameter of the wire from M. We will get this T. So T is nothing but M minus 2 times d. D is nothing but wire diameter. Okay, again you can see it here. This distance only we are interested to calculate. This distance is nothing but m. M is nothing but distance over the wires minus this diameter and this diameter. So it is 2d, m minus 2d. Okay, so if we want to calculate E, then we should know T and F. T we can calculate with the help of micrometer reading and wire diameter, and F only we are unable to substitute in this equation now. So through some derivation we will find out the relation for F, which is depends upon three factors. Capital F depends upon three factors. One is wire diameter, pitch of the thread, and angle of the thread. Okay, so based on this we have to find a relation for this capital F. Okay, so now we will see the derivation. This top portion of the diagram where the wire is resting and the thread has been zoomed in like this. Okay, we can see this is the wire and this is the flank on which the wire is resting. Okay, so this is the straight line at which the wire has been resting. The distance between pitch line and this straight line, as we have seen before, it is nothing but P by 2, sorry, F by 2, capital F by 2. Okay, so capital F by 2 we are interested to calculate now. Only what we are interested to calculate now, one second, there is a problem with respect to diagram. So we have to find AQ. AQ is nothing but capital F by 2. You can see it here. This distance we are interested to find. Okay, AQ. Okay, in order to find that we will see some derivation. Okay, so basically AQ is nothing but F by 2. Okay, so F is nothing but 2 times AQ. Okay, so now let's find out the relation for AQ from the diagram. AQ can be written as PQ minus AP. So AQ is nothing but PQ minus AP from this diagram. PQ minus AP. Okay, now let us derive what is the relation for AP and PQ. Okay, so AP, if you see here in the diagram, AP can be written as OP minus OA. OP minus OA. AP is nothing but OP minus OA. So I am writing that here, OP minus OA. Okay, so now we will find out what is OP and OA with the help of a triangle. OEP. With the help of the triangle OEP, we will try to figure it out what is OP. Okay, so I am drawing that OEP triangle separately. I am just drawing the triangle separately. This angle is x by 2. Okay, this is OEP. Okay, so apply sine x by 2 is nothing but opposite by hypotenuse. This is nothing but OE by OP. So OP can be written as OE into 1 by sine x by 2. So it is OE into cosecant x by 2. So OP is equal to, let us see what is OE in the diagram. OE in the diagram is nothing but the radius of the wire. So it can be written as d by 2 cosecant x by 2. Okay, now we will come back to this relation. AP is equal to OP minus OA. AP is equal to OP minus OA. So for OP we will substitute from this relation. It is d by 2 minus d by 2 cosecant x by 2 minus OA. OA, let's see what is OA from the diagram. OA is nothing but the radius of the wire, so it can be written as d by 2. Okay, so let us take d by 2 common. Cosecant x by 2 minus 1. So this is the relation for AP. So we have found out what is AP. In order to find out AQ, we need PQ and AP. AP is over now. Let us find out PQ with the help of another triangle. So to calculate PQ, take triangle PQC. Okay, triangle PQC. PQC. Take this triangle PQC. I'm drawing it separately here. QC P. This is x by 2. Okay, so apply tan x by 2 is nothing but opposite by adjacent, so it is QZ by PQ. Okay, so PQ is nothing but QC into 1 by tan x by 2. So QZ cot x by 2. So what is QZ from the diagram? QZ is nothing but 1 by 4th of the pitch. We know pitch is nothing but distance between two consecutive crest. So this is P. You can see here this is 1 by 4th of pitch. So replace it as P by 4 cot x by 2. Okay, now we got the relation for PQ also. So initially we have written AQ as PQ minus AP. Substitute PQ value from the above relation. It is P by 4 cot x by 2. P is nothing but pitch of the thread minus AP. AP you can get it from this d by 2 into cosecant x by 2 minus 1. Okay, so d by 2 cosecant x by 2 minus 1. Okay, so PQ we have already seen, it is nothing but f by 2. So take 1 by 2 common, it will become P by 2 cot x by 2 minus d cosecant x by 2 minus 1 whole bracket. Okay, so this 1 by 2 will get cancelled, so f will become P by 2 cot x by 2 minus d cosecant x by 2 minus 1. So in this relation we have found out what is AQ, which is nothing but f by 2, and we have found out f. From that we can easily substitute f by 2 value. So P is nothing but pitch, x by 2 you know the thread angle. So with this relation we can easily find out effective diameter. We have found E is equal to T plus F in the beginning. Okay, so T we know it is m minus 2d. With that we can easily calculate T. F we can find out using the above relation which is mentioned here. So you can first we know the thread pitch of the thread, then thread angle. With that we can easily find out what is F. Then find the micrometer reading by placing the wires, one wire within the anvil of the micrometer and the thread, another wire at the bottom of the anvil and between the anvil of the micrometer and the thread. So find m value, diameter is known one, find out t, then substitute here, you'll get the effective diameter. So this is how we have to find out the relation for effective diameter based on two-wire method. So the derivation mainly depends upon this simple relation aq is equal to f by 2. F by 2 is the initial one, so 2 times of aq is nothing but f. This is what we are interested to find out from the derivation. So aq, from this diagram we can find that aq is nothing but pq minus ap. So we are interested to find what is pq and ap. So to find out ap, we have taken this relation from the diagram. Then with the help of triangle OEP, we have found out what is OP. OA we already know it is nothing but the diameter of the wire, radius of the wire. And to calculate PQ, we have taken this triangle, and then finally we have substituted this equation. Okay, so this is how we have to find out the wire diameter using two-wire method. Thank you.